everyone! For this lesson, we are going to understand two important ideas in coordinate geometry, the distance formula and the midpoint formula. So what are these formulas about? Whenever we plot points on the coordinate plane, each point is like a location, just like places and map. Now, sometimes you want to know two things. One is how far are these 2 points from each other? And two, where is the exact middle between them? These two questions are answered by the distance formula and the midpoint formula. So why do we need them? Imagine you're tracking two players in a game, measuring how far one object moves or finding the center of a line segment. These formulas help us do that without guessing. Instead, we calculate using their coordinates. So how do they work? Both formulas come from very simple ideas. The distance formula comes from the Pythagorean theorem, and the midpoint formula comes from getting the average of the x values and the average of the y values. But don't worry, we'll break them down step by step in the next parts. To understand the distance formula, let us start with the idea. Remember the Pythagorean theorem? It says that in a right triangle, the square of the hypotenuse is equal to the sum of the squares of the two legs. To find the distance between 2 points, we imagine forming a right triangle by drawing a horizontal and a vertical line between the points. The change in x values becomes one leg, and a change in y values becomes the other leg. So if we have 2 points, in which point 1 is x sub 1 and y sub 1, and point 2 is x sub 2 and y sub 2, the horizontal change is x sub 2 minus x sub 1, and the vertical change is y sub 2 minus y sub 1. Using the Pythagorean theorem, we have distance squared is equal to horizontal change squared plus vertical change squared. And if we take the square root of both sides, we get the distance formula. So, the distance between 2 points is the square root of x sub 2 plus x sub 1 squared plus y sub 2 minus y sub 1 squared. This formula works for any 2 points on the coordinate planes. Now that we understand how to get the distance between 2 points, let's talk about finding the midpoint. The midpoint is the exact center of a line segment that connects 2 points. In simple words, it is the point that is halfway between the two given points. To find it, we do something very natural. We take the average of the x values and the average of y values. Why average? If you think about being halfway of a number line, you just add the two numbers and divide by 2. The midpoint formula is the same idea, just applied to both x and y. So, if our 2 points are x sub 1 and y sub 1, and x sub 2 and y sub 2, the midpoint is found by x sub 1 plus x sub 2 over 2 and y sub 1 plus y sub 2 over 2. This gives us a new point, the point exactly in the middle. Now that we understand the distance formula and the midpoint formula, it's time to apply them in actual problems. In the next part, we will solve 3 problems and I will guide you step by step. Make sure to follow each step carefully. Let's begin with example 1. Example number 1. Determine if the points 14 and 7, 2 and 2, and negative 4 and negative 1 lie on a straight line. To answer this problem, let us use the distance formula. The distance formula helps us calculate the exact distance between 2 points in a coordinate plane. By comparing the distances between the points, we can determine whether the 3 points lie on a straight line. Let's label our points to make it easier to refer them in calculations. For point 1, we have 14 and 7. Point 2, we have 2 and 2. And point 3 will be our negative 4 and negative 1. Also, we will use d sub 12, which will represent the distance between point 1 and point 2. D sub 23, which will represent the distance between point 2 and point 3, and also D sub 13 to represent the distance between point 1 and point 3. Now, let's substitute the x and y values of point 1 and point 2. For point 1, we will label its x value as our x sub 1 and its y value or y sub 1. For point 2, we'll label these values, these x and y values, as our x sub 2 and y sub 2. Now, let's solve the distance between them. So our x sub 2 is 2 minus our x sub 1, which is 14. Then our y sub 2, which is 2, and our y sub 1, which is 7. Square root of 169 is 13. Therefore, the distance between point 1 and point 2 is 13 units. Next, we find the distance between point 2 and point 3. Now, let us label the x and y values of point 2 and point 3 as the following. For the x value of point 2, we'll label it as x sub 1, the y value as y sub 1. For point 3, we'll label its x value as x sub 2, and its negative 1, which is its y value, as our y sub 2. Now, let's substitute these values in our formula. Now, the square root of 45 is 3 square root of 5. Here, we see the distance is 3 square root of 5 units. This exact value is important because we will compare it with the other distances to check for collinearity. Finally, we find the distance between point 1 and point 3. Let's assign its values. For the x values of point 1, we will label it as our x sub 1, and for its y value, which is 7, we will label it as our y sub 1. For the point 3, its x values will be x sub 2, and its y value, which is negative 1, will be our y sub 2. Now, let's substitute these points in our formula. So, the distance between point 1 and point 3 is square root of 388 units. Keep in mind that the largest distance is always the one between the points farthest apart. To determine if the points lie on a line, we check whether the sum of the two smaller distances equals the largest distance. That is, we check if the distance between point 1 and point 2, which is 13 units, plus the distance between point 2 and point 3, which is 3 square root of 5 units, is equal to the distance between P1 and P3, or point 1 and point 3, which is the square root of 388 units. Converting the decimals to make comparison easier. So we have here 13, which in its decimal form is 19. It's approximately 19.708, and its approximate, which is 19.967. Since these are not equal, the points are not on a straight line. Therefore, b sub 12 is b sub 13 is not equal to b sub 13. So in conclusion, the points 14 and 7, points 2 and 2, and points negative 4 and negative 1 do not lie in a straight line. Example number 2. Prove that points A, B, C, and D form a square and find a diagonal. To answer this problem, let us use the distance formula. The distance formula allows us to calculate the exact distance between any two points in the coordinate plane. To prove that these points form a square, we need to check two key properties. 1. All four sides must be equal. And 2. The two diagonals must be equal. If both conditions are satisfied, then the points form a square. We will also calculate one of the diagonals at the end. So we have here the given points. For point A, we have 6 and negative 13. Point B, negative 2 and 2. Point C, 13 and 10. And point D, 21 and negative 5. First, let's calculate the distance between point A and point B. So we have here the x and y values of A and B. For A, 6 is our x sub 1 and negative 13 is our y sub 1. For the point B, its x value will be x sub 2 and its y value will be y sub 2. Let us substitute these values into our formula. Therefore, the distance between A and B is 17. Moving forward, let's calculate the distance between point B and point C. So the x and y values of B would be our x sub 1 and y sub 1. The x and y values for our point C would be our x sub 2 and y sub 2. Let us substitute these values into our formula. Therefore, the distance between point B and point C is 17. 17 units. Now, let's calculate the distance between point C and point D. For the x and y values of our point C, we will have it as our x sub 1 and y sub 1. For the point D, its x and y values will be our x sub 2 and y sub 2. Now, let's substitute these values into our formula. Lastly, we will calculate the distance between point D and point A. So we have here our x and values for D and A. For D, we have 21 and negative 5, which will be our x sub 1 and y sub 1. For point A, 6 and negative 13 would be our x sub 2 and y sub 2 respectively. Now substitute these values in our formula. Therefore, the distance between point D and point A is 17 units. Since the value of all four sides are equal, which is 17 units, therefore, this satisfies the first condition of a square, which all four sides must be equal. Next, we check the diagonals. In a square, the diagonals must be equal in length. First, we have A and C. The points for A is negative 6 and 13, which will be our x sub 1, y sub 1. For C, the points is 13 and 10, which will be our x sub 2 and y sub 2. So we have here therefore, the distance between the diagonal A and C is the square root of 578. Now let's find the distance between B and D to find the diagonal BD. So first we identify the values. For B, we have negative 2 and 2, which will serve as our x sub 1 and y sub 1. And for D, we have 21 and negative 5, which will serve as our x sub 2 and y sub 2. Therefore, the distance between B and D, or its diagonal BD, is a square root of 578. Since the diagonals are both equal, as we can remember with diagonal AC, both measuring square root of 578, this confirms the second condition for a square, in which the diagonals must be equal in length. Since all four sides are equal and the diagonals are equal, the points A, B, C, and D form a square, and one of the diagonals of the square which is diagonal AC, is square root of 578 units. Example number 3. Two vertices of an equilateral triangle are point A, negative 4 and 3, and point B, 0 and 0. Let's find the third vertex. We are asked to find the third vertex of an equilateral triangle. Recall that all sides are equal in length. So, the distance from C to A must equal the distance from C to B, and both equal the length AB. So we have here, AB is equal to AC is equal to BC. First, let's calculate the length of the known side AB to know what the other sides must be. Let us use the distance formula to find the length of AB. So we have here the x and y values of AB, so we will label this x value of A as our x sub 1, same with 3 as our y sub 1. For B, this x and y values will be our x sub 2 and y sub 2. Let us substitute these values into the formula. So all sides of the triangle must be 5 units. Now we assume the third vertex is C, x, and y, which we need to find. Next, let's use the distance formula to set up equations for AC and BC. Next, let's use the distance formula to set up equations for AC and BC. Recall that the length of AB is equal to 5. In equilateral triangle, all sides of the triangle must be equal. Therefore, the length of AC and BC must be equal to the length of AB, which is 5. To set up the distance equations for AC and BC, Let us assume that the x and y values of c is x and y. Now, substitute these values. For a, let us use -4 and 3 as our x sub 1 and y sub 1. For our c, let us use x and y as our x sub 2 and y sub 2. Let us use this for Now, we have a system of two equations with two unknowns x and y. Let's solve it step by step. We'll start by expanding the first equation to simplify it. Notice that from the equation of BC, x squared plus y squared is equal to 25. We can substitute the value of 25 in this equation. So x squared plus y squared is equal to, will be going to 25. So as we substitute it, now we have 25 plus 8x minus 6y is equal to 0. Simplifying it even more, now we have 4x minus 3y equals to negative 25 over 2. Next, we'll express y in terms of x. This gives y in terms of x. Now, we can substitute this into the equation of BC, which is x squared plus y squared is equal to 25 to solve for x. Now, let us substitute this equation to the equation of BC, which is x squared plus y squared is equal to 25. So now we have, simplifying it would take us to, now we have a quadratic equation for x. Time to solve it using the quadratic formula. Now, let us use this quadratic formula to solve for x. Recall that for the quadratic equation, this is the a, this is the b, and this is the c. So we will substitute these values into the equation to solve for x. So, these are the two possible values of x values, meaning two possible positions for the third vertex. Next, we find the corresponding y values. Let us substitute these x values to our y value to find out the possible y values. So first, let's start with this first x value. Then, the first y value is equal to 3 halves plus 2 square root of 3. Therefore, the second y value is 3 halves minus 2 square root of 3. So these are the two possible locations of the third vertex of the equilateral triangle. The triangle can be oriented either close or above, below the line AB. And that wraps up our discussion on the distance and midpoint formulas. Today, we learned how to calculate the distance between 2 points using the distance formula and how to find the midpoint of a segment using the midpoint formula. We also saw how these formulas can help us verify geometric relationships, like checking if points are collinear or finding diagonals of shapes. Remember, these formulas are not just about numbers. They help us visualize and understand geometry in the coordinate plane. I hope this discussion helped you see how algebra and geometry work together to solve real problems. Keep practicing these formulas and you'll get more confident in applying them in different situations. Thank you for watching, and I hope you continue exploring the beauty of mathematics.